Hello, everyone. My name is Wahid Lutfi. I'm going to be presenting you with R programming language on Windows platform, and it's going to be a full course. This full course is going to be from zero to hero. Basically, you don't have to be at the zero level to start, but it doesn't matter even if you did not hear the name R programming language or you're not familiar with any programming language. I'm going to be discussing a lot of basics first, and then we go to intermediate, and then we go to advanced, and then so this is a full comprehension course, a list of topic that I'm going to be presenting it to you. This is the entire course is going to be covered in one session. So you're welcome to learn from it and make some comments and just look at it. For the content of this course, I have present you the agenda or structure of the course. So we're completely organized to teach you the basics, the intermediate, the advanced level, from everything about R, everything that you need to know. Rproject.org is the website that I'm going to be downloading the software. So from r-project.org website, we're going to also go to r-project.org CRAN page. CRAN stands for Comprehensive Archive Network. So R is for R language itself, Comprehensive Archive Network. And this course is also comprehensive, so you will be covered with all the topics that you can think of in R programming language, whether it's database, whether data science, or whether it's developers, coding, and all kind of functionality and data types, data structure. I'll be covering all of it. So we will have lab time activities also on this course. I'm going to be using Windows operating system. If you're interested to learn R programming on Linux and platform, I've already posted some videos on Linux Rocky version. You're welcome to watch that one. And then at the same time, I may make more videos on the Linux Rocky, Red Hat, Linux Ubuntu, Windows itself, Windows operating system. As people show interest and make some comments, then I would fulfill the needs for it. And this course is basically a combination of basic stuff, intermediate, advanced levels for all kind of students, data scientists, developers, administrator, DBAs, because when you're working with MySQL database or MariaDB or Oracle or some other database or a set of data sets, you're going to be using those ones in the background to just code R to use the data or the big data and analyze it and come up with some visualization or data analysis for it. So it doesn't matter where you are at, I'll have something for you on this course. And then we're going to talk about R console. On the previous, I mentioned that I'm going to have a lab activities. On the lab activities, I'll show you how to install R, which is the R console, and then RStudio, which is on the rstudio.com website. Or and the other ones I mentioned to you on the r-project.org, the list of comprehension software CRAN is available, and from there you can get all software, including the R console, as well as all the R packages, third-party packages or extensibility of the programming language with those packages. You can see that there's so much for you. I'm going to be also talking about RStudio, which is the integrated development environment. I'll show you the RStudio in detail, and then I may not cover every function and every part of the IDE, but I may just jump in and from one to other ones, depending on the structure of this course, how it's going to be benefit you. Okay, so all of these ones will be presenting to you on my website, which is youtube.com/MyWebUniversity. I'll be also talking about our programming language with using another, aside from the IDE that RStudio comes with it, you can also use Visual Studio Code, which is also open source. And then you can just run your code on Visual Studio Code. All you have to do is that for the Visual Studio Code, install some of the extensions for our language to support our coding, and then you can run and debug your code easily. Similarly, you can do a Jupyter Lab IDE for our language. So I'll show you Jupyter Lab as well, and that is very nice to just work with Jupyter Lab inside R. R is mostly compared with Python programming language, and then some people say which one is better. I think for every programming language, there is some advantage for one versus the other one, depending on your usage. So if you're a developer doing statistic, R is your main language you should work on. And if you're like a maybe general purpose programmer that you want to use, C++, C, Python, all of those ones will serve you better. And then some of the visualization and graphics on our language is very, very much available. At the same time, the ease of use of our language is way much simpler than Python, and Python is much simpler than C and C++. So depending on what you want to use and where you want. If you want to use like a R vector, obviously R is the easiest way to initialize a vector and manipulate a vector. But if you have to do it in C++, you may write a pointer, you may write a class, you may write an abstract. A lot of these details are hidden behind the scene that you have to do as a developers. But with R, it's much easier. Even with Python, it's much easier, yet you have to import the NumPy module, you have to import other module, like, for example, plotting, you have to load the matplotlib. For database connectivity, both of them are having these features. I'm going to be mentioning to you some of the cool features of our language with, for example, MariaDB. I just made another video which I posted how to install MariaDB and how to use it. You're welcome to watch that video. It's an hour and 15 minutes, but it covers a lot of MySQL, structured query language, SQL, and data definition language, data manipulation language, data control language, a lot of examples with HighDSQL, and then there's so much into it. You will learn a lot of it. Make sure that you share those knowledge once you learn it to the community that you live with your best friends or with loved ones and families, and so everybody could benefit from it. By sharing, you care. So I'm going to be talking about R also on the Markdown. Both Python and R, like Jupyter Lab, also have the IDE for Markdown language, which is going to be very good for generating reports. And on this one, you can see we start with R Markdown file that is save.rmd. And then once you give it to the KNetR, which is another package for report generation, very specialized, that is done on the R language. It's a package that supports you to build a lot of kind of Markdown documentation. And this pandoc is another module that is a special purpose for the same kind of generation, whether you want to do a PDF here or HTML file or Word document. You can do from any of these ones, as long as you have these two modules. But for PDF, for example, by default, this will generate HTML code. And if you want to do a PDF version, you have to install additional modules within R. So that be on the lookout if there's need for it, you have to do that way. I'm going to be also talking about what is R programming language, and then I have on this list under the R a lot of the scripts that I have already written. I'm going to go through them. This screen that you're seeing is kind of a lecture part of the this course. So it's about 5-10 minutes or maybe 15 minutes, depending on how much I talked about each slide. If you are just already knowledgeable about some of these things and you want to skip it, you can skip the lecture part and jump right in when I go to the lab part. So you're welcome to do that way as well. Are supported on multiple platforms, a Unix operating system, which is Mac OS X, and then also another Unix machine like Solaris, some microsystem is also there. FreeBSD is another one, OpenBSD is another one, Unix. But nowadays, mostly it's people, when they talk about Unix or Linux, they are talking about Linux. Linux platform, you can run it on Rocky, you can run it on Ubuntu, you can run it on Red Hat, and a lot of other versions, Debian and Fedora and everything. So on the Windows platform, obviously this video is on the Windows platform, so I'm going to be showing you as I mentioned in this session, the R session is on Windows platform, this one. And Windows 11 operating system, I'm using it. As you can see from my background, it is a Windows operating system. And the slide that I made on the background was last Sunday. So this 9/8 is 2024 is you're seeing the timestamp of the slide that I made on that day, but then I had to make a comprehension kind of like presentation for you to present you with everything that you need to know. That way, today is 9/21, Saturday. I'm going to present you the whole lecture today. And these are my days off that I'm going to serve the community. I hope you benefit from it and you also pass it on the knowledge to other people that are your friends and families and on the community. We're also going to be talking about R.version and system information, how to detect that one when you install it. R automatically comes with a base packages. This is like the building block of R core packages that you need to just do R as a programming language or use it as a functional programming or even as an object-oriented programming. R support both functional programming and object-based programming, but it's mostly functional programming. So our basis provides all of that. Under the CRAN, which is comprehensive archive of network for R, is a list of packages that I will show you there. We can do it. And then R has extensive documentation. I'm going to be showing you how to use those documentation as well, where to get them and how to search for it, how to get help, all that information as well. And then I'm going to be talking about R data types. And data types and data structures, both of them are very important in every programming language. And R supports 6 different data types and many different data structures. So we're going to be talking about those ones. For example, we're going to be talking about R data types with numeric, integers, double, logical, complex, and characters. Those are the 6 data types that I just mentioned to you. And then I'm going to also be talking about data structure, which is vector. The core part of R is vector. Vectorization made it R one of the most kind of used programming language for data scientists and data manipulation and data visualization. And so arrays and other programming language are being used. And R also you have arrays. Array is like a data structure that you can get element by indices, and then each element could have a separate kind of element, and the data type is all homogeneous, which meaning that once you define an array to be type of character, everything is character. You cannot have a mix of character and integer for arrays. Similarly, for Python programming, and C++ arrays like that. So it is homogeneous and it's all data types based on the kind of linear models, right? So the matrix is similar to array. It is still 2-dimensional, 3-dimensional. On other programming languages, like C and C++, matrix is called a vector, for example. And then you could have the same kind of arrays. A combination of arrays and matrix could be, and vectors could be in a list. List is a data type of a structure that supports heterogeneous data types. So you could have characters, list within list, you could have arrays within list, and you could have matrix and vectors and all kind of variables. And the list, yet a list is not like as maybe I don't say as efficient or as useful as data frame. Data frame, for example, is coming as a concept of similar to like a table and their database. You can have data frames that you could have a data set, and within the data set, you could be interested in a chunk of the data set, and that chunk could be your data frame. And with data frame, you have attributes and columns and fields like similar to like an Oracle database or MySQL database, or Oracle, MySQL, Microsoft Access, SQL Server. A lot of those ones, or you can do data manipulation, data control language, data definition language, and all of those ones within the package called tidyverse. And dplyr, you can manipulate a lot of the R coding with this data sets and manipulate each one of those fields based on columns and fields, the attributes that they are assigned to it. And then we will show you, for example, on the data frame, when you're looking at a data frame, you can just pull some header of it, some tail of it, some view of it, and plot them, everything. You can do that one. Factors are for data type with categorization, like fruits, and then maybe colors and other ones. You could categorize it by a certain factor, and then you do those ones. Also in C and C++ and Python, it's enumeration data type. So you have these ones. A table is almost like a database kind of table. So a table is similar to like a table on Oracle, on MySQL, or Sybase, or Microsoft Access, or any other database, a structured query language that you're selecting some information from a table. You can get this data frame and convert it to a table, which is going to convert in a very nicer way of a table kind of data. So you have columns and fields, and you can access certain attribute of it using dplyr package of R language. So these are, and then attributes is a concept of object and classes. So in programming languages, usually in C, if you're familiar with C, you have struct and union and class coming in C++. And then also in Python, you have class and list and other ones. But when you are talking about class and object, a class could be an employee, a class could be a car, a class could be furniture, and then each instance of that class, a class as a teacher is an instance of that class. But teacher has certain properties and attributes, teacher name, teacher ID, teacher social security number, home address, all of that one, or attributes, height, name, age, and everything. And then what teacher can do, or methods, functionality. So in functional programming is called function, and object-oriented programming, that's called method. And then when you are using a class, an object that you create, you can just get a data frame and assign it to a variable, and that variable is an object. Now, all these properties that I was telling you about, and that you can get the table on the columns, or table on the columns, or data frames of columns, all of that one is manipulatable by coding. So I'll show you some of that one also. Our base packages, the function, this one is the core part of it. So it does provide you to do functionality with everything that you do, like sequence, and then adding numbers and multiplying and so on. All of that one I will show you as well. Stats, everything is statistical. And so R was borrowed from S language, or R is the successor of S language, which S language was built in 90, maybe 73, around 73 or something, in Bell Laboratory of AT&T. And then R is built, I believe, in 1993. I don't, just don't quote me on that timing. And then you could just look it up. So R is similar to S, but it has a lot of other functionality that is why it's a different language now. It's a successor of S language. R also has a package called FS for file system. I'm going to be showing you demo of file system. It is important to know how to store files, how to retrieve the data, how to access them, how to get an operating system list of commands. Everything that you need to know about file system is on this package, and I'll show you that. Our database and data manipulation, we're going to talk about dplyr. I already had a video about data frames using dplyr package. So just look at that video and then you're going to see a lot, but I will show you some more today. And then a list of other packages that I mentioned here, some of them, these are not the only one. As you can see, the 3 dots with more, that I could say that there's thousands of packages. So some of the main packages that you should know definitely is base package, stats package, utils, file system, dplyr, graphics, tidyverse, and a lot more. I mean, obviously, ggplot2 and other ones are all coming as a result of some dependency with tidyverse and other ones, which I will show you that as well. And then R for data sets and data visualization. So basically the core part of R that is kind of like compared sometimes with Python, that R is much easier to work with data sets, and then at the same time manipulate the data and get a graph of it, plot of it. So I could show you in 2 lines of code, you could get a data set and then a plot for it. And then with Python, yeah, it is simpler there. I'll show you also in Python. You might want to watch my Python courses or videos, because I taught at least 5 courses of Python programming language on Pasadena City College back about 2 years ago. So I did provide, provide you a lot of videos on Python, including NumPy, and then at least maybe 7 videos for NumPy itself, the regular expression and Python. There's a lot of data sets kind of manipulation for Panda, Python, and Matplotlib, and URL Lab, and NumPy, and other ones that you can use to do data visualization as well. I'm going to compare the 2, how easy it is in one versus the other one. But there are apple and apple comparison is really hard. It's almost like saying, is Cristiano Ronaldo Ronaldo is better or Messi? I would say both of them are better than each other, but they're both at the same time or the best. So you cannot just say one is better than the other one, or is Maradona better than Pele, or Pele is better than Maradona, or any of those 4 or any other ones. They play a different era, and then at the same time, they are playing different position. They're manipulating, having teammates that are in different teams. They play and they get passes that are incredibly from Xavi or Iniesta versus somebody that maybe Ronaldo, you could say that he's kicking it from far away and score a lot of good kicks. And then he's good on headers, and Messi is very good at dribbling. So a lot of those things you can just look at R and Python similarly. So R is a statistical software, where Python is AI kind of software and general purpose software. And so for one, comparing it, saying that you need to do statistics. Should I do R or Python? Go with R. If you have to do AI stuff, go with um, Python. And if you have to do maybe data science, you can do either one, depending on which one you're looking at. And if you're doing it game programming, obviously go with C++. But if you have to look at the pointers and the structure of it and look at which one is easier, either go with Python or rather than C++. But at the same time, like R was written in Python, I'm sorry, R was written in C, R language itself in Fortran. So sometimes when we look at the C++, before C++ came in, there was C language. Before Python came in, there was C language. So C language is the mother of all languages that support every one of them. So in a way that, yeah, you can't just take credit from like giving Messi everything and then think of Maradona and Pele that set the stage for them. So they learn everything that Maradona and Pele did, and Cristiano Ronaldo and Messi, they add on their own features. So in a way that, yes, you look at Python and see Python and maybe R language is much easier to write code and much friendlier and much nicer interface than a C programming language that you could see, or C++, that all you see is the $ symbol rather than IDEs and other ones. Although there are IDEs for everything, right? Flippers and then Visual Studio Code and a lot of other Borland, C++, we were using all of those things in the past. So let's get back to data visualization. And then I want to thank you for watching it. I'm not done. We're just done with the lecture part of it. So let's just go on to my channel. I want to thank you for watching, and I want to make sure that you subscribe to our channel. If you do, I would really appreciate it. And if you don't do it, that's okay also. Please make sure you share the knowledge with your friends, whatever you learn or whatever I provide you. If you can pass it on to somebody else who could benefit more than you do, please share it with them, and they will just thank you later for what you have done to their life. You inspire somebody by just giving him some kind of knowledge, and they will appreciate that. So I'm going to be showing you the RStudio here. And then before I show you RStudio, this is the RStudio interface. And then right here is the R console. So this is R console. I'm going to type in quit here, quit, and then you can type in Q here. That's similar to typing quit there. So I'm going to say yes, no, don't save it. Here I'm going to type in quit rather than Q. So for short, you could do that one too. And then when you type in quit, it's going to just exit out. So at this time, I don't have R language running or anything. So I'm going to just show you the first page, which was this one, the agenda of what we are going to be talking, right? So I present you on the PowerPoint here. I'm going to look at the presentation page on this one. So this was the topic that we were going to discuss, our full course. And then the agenda of the class is I'm going to take you to rproject.org website first. So let's get to do that one, okay? And then at this time, I'm going to go to rproject.org website, which I don't have open here. And then I'm going to type it here. I'm going to say HTTPS r-project.org, that one. So we're going to go to rproject.org. As you can see, this says the R project for statistical computing. And R was borrowed from R statistic. So this is our first slide that I'm going to show you. This is the entire page of R. And one of the page that I was showing you is a CRAN, which is comprehension R archive network. If you click on this one, it shows you where you can download all the R packages from. This is CRAN is a mirror, so it is coming back to the r-project.org, and this is called CNAME, canonical name, and DNS kind of information. And you can see these two keys. That means it's a secure page, HTTPS, and this certificate is secure, connection is secure. So it is safe for all the downloads and everything. And then when you're looking at this one, you can see all the list of URLs that are on the CRAN page. And then on this one, you can see here, zero cloud. The first one that you want to click on this one, if you know, for example, that where you are located, obviously everybody knows I'm located in USA and California. So the Oregon State University is close to me. I would click on this one. But if you didn't know which one is there, it's much harder to do it. They made it easy. Just go to cloud-r-project.org, and then right here, automatically it will detect based on your IP address of the machine from where you're connecting it to. They will just get to the closest area that you can download it from. So the R archive downloads, when you can see here, R download for Windows, Linux, Debian version, distribution of Debian, Ubuntu, and then Fedora, which is Fedora is the distribution itself. Red Hat is also based on Fedora, Linux Rocky is based on Fedora, and CentOS is also based on Fedora. Ubuntu is another distribution, which is also Debian. Download R for Mac OS X, and then download for Windows. Since I'm working on a Windows machine, in order to know which machine you are on the Windows, you can open a command prompt or just type in about here, about your PC on Windows, and you will see that it is a Windows operating system. And right here it says Windows 11 Professional, and then this is a 64-bit operating system. As you can see the details here, somewhere here it says the processor 64-bit. That means I can download the 64-bit file, right? So if you want to type in system information here, will be similarly giving you that information, Microsoft Windows 11. If you want to open a command prompt, so many ways you can get this system info, and then say 5 more, it will just give you the operating system, everything. Sorry, my neighbor's dogs are barking. I'm going to pause it for a second to make sure that it doesn't get too noisy. Actually, they stopped, so I'm okay. So Microsoft Windows 11 Professional Edition, you can see, and then the processor, 64-bit, everything is there, right? So I'm going to close this one. We got that information. I'm going to close this one. So we know that I want to get Windows 11. And then right here under the base, you can see it says the click R. If I go back on this screen, it says install R for the first time. If you're doing it for the first time, obviously you click on the base, and then the version that is currently available is R 4.4.1. And then you just download this one, and then once it comes in on your machine, then you go to your Windows directory under the download directory. So right here, and then right here is most likely RStudio is there, and then R console is there. This executable, as you can see, I have it here, and then R 4.4.1. You double click on this one, it will go through the installation, which I don't need to do that one. If I just do this one again, it's going to just say you already have it. You accept it, saying that go ahead, run it as system, and it says go ahead, install it as English, and then it goes as through the installation. So it gives you the path. And then at this time, I'm going to just say don't do this one, because I actually, if I do it, it's going to just overwrite some of the changes. And then mostly it's not going to clean anything, but I don't want to do that one. So you can continue, since I have it already, and I already add the icons, everything. I'm just going to tell you how to do it. So that is one way to get the installation. The second thing is that you need to, so this is giving you for the R console. But for the RStudio, you need to go to RStudio, and then that's also HTTPS secure page. Hypertext Transfer Protocol secure, S means secure. RStudio.com. So that's a .com page, and you can see here, it comes in with some cookies, says accept all cookies, I do. And then it goes there, and then eventually you can click on the download page and then find out the open source version of it. When you do that, this one basically, there's a lot more advertisement than actually showing you the page. Oh, sorry. Yeah, it is that one. But it took me to this. Let me just type in rstudio.com. And notice if you just are getting redirected, this is correct, and it says that one. Somewhere here it should say, let's see, get started, and then somewhere it should say, go ahead, download it, and then notice there's a lot of kind of like advertisement saying that we're so good and everything. So let me just go to google.com and then say rstudio.com and download RStudio. So RStudio, you could search it this way also. And notice that it takes you the same page and download page. But this time I'm gonna get to the download directory directly. So you can see this posted download. I could have just typed in download after it, and it takes you there. And then right here, installing it. So it says download and install R, and download and install RStudio Desktop for Windows. So you click on this one, and then this time it will just download that one. And then also you have for the community version, which is free, and then you can do that one. So I believe this one is already, yeah, it's the same one. So I have the version 2 of it, right? So if you double click on this one, because I already detected, it is going to go through RStudio, and it's going to try to install it for me. And I say, yeah, go ahead and do this one. But notice that this screen comes in with RStudio. You select it, and then you choose the path where you want to install it. Click next, and then choose all the option here. If you go by default, that is good enough. I'm going to cancel it, and so I will assume that you will do the same. This is pretty straightforward. All you have to do is just download the RStudio. Once you have it on that directory here, RStudio, you double click on it. And I just download the second one to just demonstrate for you. So once you have it, RStudio, and it is downloaded, installed, you have either a R console for the first one, and then here, this is the interface for the R console. If you want to see like a little bit bigger, because I'm making a YouTube video, so then I go to GUI preferences and then choose the text font to 20. 20, and then now it's bigger. And then right here, you can have the scroll bar, and right here, you can start writing R code. So if I say print hello R, you can see that it is coming there. And if you just say, well, that's nice, can I just do some other codes? Obviously, you can do a lot in here, but I'm going to just show you, like, for example, 1 to 10, you print a vector like that. And you say type of 1 to 10, you can see that this is a type of integer. So you can say, well, give me the class of it. It's class of it is integer also. And then you could do a lot more. I'm going to just do that information. So if you say, for example, can I just do that R right here, and then multiply every number of the vector by 2, yes, you can. And then notice that I did it times 2. And that means that this one is 10 times, done the same thing with the numbers. So instead of doing that one, you want to do this. You say, whatever is each vector, each element to the power of 2. And so 2 to the power of 2 is 4, 3 to the power of 3 is 9, and so on. 10 to the power of 10 is 100. Similarly, if you want a cubic feed it, you just do that. And similarly, if you say, give it for these numbers between 1 to 1000, you could do that one. So a lot of R code is very, very easy. I'm going to show you a lot today. At this time, I'm going to quit out of this console, and I don't need to do the demo on console because we have a much nicer IDE, integrated development environment, and we could just use that in the state, which is this one. I'm sorry, which is this other one right here, RStudio. So when you install the R console and RStudio, you can also go to your command prompt and type in R, and notice that R 4.1 is there and RStudio is there. You can right click here and then pin it to your start. That's what I did, and that's why it's done. Similarly, with this one, pin it to the start, and you can pin it to the start menu or pin it to a taskbar, and it's going to come there. So you can also start off from here, right? So if I just double click here, it will open it. And if I click exit, it will close it. How simple is that one, right? So this interface, the RStudio comes in, it has about 4 different windows or panes. So the first window, which I'm going to show you here, is called the source window. Because of this, everything that you write in R language or Python programming or something, you can write it here once, and then you could save it. And every time you load the RStudio, that program, the source code will be available. Then you can just have as many of them as tabs. For example, this course, I'm opening a lot of them, right? So each one of them, as I go to the right, I can see like a lot of them. When I say I'm going to make less comprehension of this course, I am going to show you databases. I'm going to show you a lot of stuff, Python inside R. So you will learn a lot, and believe me. And you will be making me more happy if while you're learning, you share your knowledge with your friends and loved ones, so everybody else could learn and benefit from it. And if you just write and make a nice comments to me, I would also greatly appreciate that as well. So I do more videos like this. But at the same time, right here, I'm just inside the R language. As I showed you on the PowerPoint presentation, and which was that page right here, PowerPoint presentation here, if we go to present it, you can see we were talking about our project. So we're done with that one. I showed you the CRAN, and now I am already in the lab activity, installing the RStudio and our console. We covered this topic, and now I'm inside RStudio, and most of the discussion will be on RStudio before we jump into Visual Studio Code IDE. Okay, so let me just come back in here on RStudio. On this one, I told you that this one has 4 panes or 4 windows. Each window that you work on, it has the source. This left top window is the source. You can run the entire code at once by clicking the source. It will source this code. And Bash and other programming, if you're familiar with C Shell and Bash, there's a command also that you can say source the name of your script, and will run it for you. But you have also a run option. And so you can point to the first line and say run. It will run only that line number. Then it will move on to the next line, and the next line. So this lines with the pound in front of it, or comment. Comment And every programming language has a different kind of syntax. In R, there's only one line of comments that you can put a pound. If you want to do multiple line of comments, you just highlight the whole thing and then you use Control Shift plus C. It will make the entire thing as comment in front of it. So for example, if I just want to say this is sorry, and this is a multi-line, and then I'm going to notice that multi-line comment, and I use R. Wow, as soon as I paste something R, and then it adds out a lot of the IDE stuff. So R, and then let's say I just highlighted some stuff here, and then I want to say comment all these 3 lines. So you type in your line, you select it, and then do Control Shift C, and it will automatically and does the combination. So the syntax that I used was control character CTRL plus Shift plus the letter C. So that would make those combination. I'm gonna just remove this one. I don't need it, and I just highlight it. Now, in order to save it, I could just say Control S right here. You can see IDE. It also has Control S. So if I just say Control S, automatically saves my information. Or I could just click on this one. Now, notice that this icon is disabled now, because I'm not making any changes. The minute I add some changes, it's gonna just do it. And then I can click here, it's Control S kind of things. So now if I just remove this one, I could just save it again, and this is the last change I did. You can also do a file save as, so you can have a backup of it, or save the same file by pressing Control S. So you have this option as well here. And then here you also have file under the package. But let me just introduce you to this window first. So this window has the source code that you're writing. So disregard to how many lines or how many thousands of lines you have. You don't want to have thousands of lines on the source code. You want to just have it modularized. So if you write one script or one function for this purpose, write another one for this purpose, write another one. So that way your code is not going to be like too extensive to write it in once and just look for it, and it is going to be garbled. Sometimes harder to just trace it. So you have the source code here. At this time, you want to just run the code. Basically, you have this option of run. Or you could just select the information and then just press Control Enter on Windows. On Mac, it is Command and Enter. So on every line that you run, if you just run this one, notice that this one is just loading the package there, because there's some R code that I did here that says load the package MySQL and DBI. So later on, it will be on those lines there. And then source it, you also run the whole thing at once, okay? And then the next window here that you have is the output window, as well as whatever you type in here. If you just say 1:5, like I showed you there, and I say run this one, and then it runs 1:5, and it is going to be sitting there, and then it produce the output here. I could also point here, let's say I make this one to 10, and then I just point there, Control M or Control Enter, it will run it the same way and there. And by pressing this one. So whether you use a keyboard or your mouse to point to this one and just keep saying that one, and you could say print a statement, whatever you want to do, add to it, then you could do that one, right? So this is your pane that is going to say, this was your statement, this is your output. This window is basically your output window. This window also has the console, which is getting this, as well as the terminal, and then background jobs, if you're running any background jobs. I think I'm running any background job, so this will be empty. But inside terminal, when you open a terminal, you have this option. So another shortcut that I'm going to introduce you is Control-Shift-1. Control-Shift-1, when I press, I will have this screen, my main window. Look, Control-Shift-1, that window just showed up. Next time I use Control-Shift-1, it will just put everything back, right? So if I want to see this window and the big one, Control-Shift-2, the number 2, right? Not F1, not F2. It is Control-Shift-1. To go back to the main one, Control-Shift-1 to see the first one, Control-Shift-2, going back, Control-Shift-2, getting this screen. Now I'm on this screen. I want to just clear my screen. Notice here you have a OK, and then it's if you're going in loop, this will be a stop sign, kind of like saying that there's more data coming in. This will be red and until your program finish. Right now, it is waiting on the console and it is ready for me to execute more commands. So I can also click on the brush to clear this screen and just type in here. Now I'm on the console. If I want to say, show me the R.version, I can get the R.version information and it will tell me that this R.version that I have is 64-bit operating system. MengGW32 is because of the terminal. I'm going to show you this one. This is stand for minimum GNU for Windows 32, and it's actually 64-bit. This one platform is a 64-bit MengGW32, but also supports backward compatible with 32 version also. And the year that was done in 2024. A lot of this information you can see like R.version. And when you put $, notice that a lot of these details that are here on the field, you can get it. For example, if you need the platform, just do that one. It will just only give you the platform. Similarly, if you say R.version, $ architecture, you can get architecture, and that should say x64, 86, 64-bit, that will do that. Similarly with all these other one, major version, minor version, and then the year and everything else, right? So if you want to get like R.version.string, that one, it will just give you one line string, R.version, full detail of it here also. So at the same time here, I showed you this. If I just clear my screen here, or Control-L is also a clear screen. So if I just run this command here and then Control-L, it will just do the same thing as clicking on this brush window. So now you're here, you want to just say, let me just go to the terminal, see what the terminal offered here. So normally when you click on the terminal, it just says your current working directory, your user ID at the host name, and then the name of the OS and everything. So if I just clear the screen here and say here, uname -a, that will tell me the same thing that I showed on the bottom. And so MengGW and T10, it says that the name of the host name is algorithm. So if I type in host name, it will tell me its algorithm is the host name. And then R.version is not found here, right? Because I'm inside the bash. So some of the command that you're typing in is MengGW, which is minimum GNU Windows 64-bit. So I'm going to do a clear screen. That command is understood. I type in pwd, print working directory, that command is understood. If I say dir, that command is understood. These are operating system command, but when it says MengGW, that is minimum GNU for Windows 64-bit. That means that not every command that is there is going to be available, like cat etc host. And notice that if I say etc host file, that is a file there. But if I say cat etc host file, that shows me that one. And if I say cat -n, it give me line numbers. And then if I do a more etc host, it does not understand more. It says more is not found. And then if I say alias, now alias is there. So if I say page etc host, that is not either there. So if I want to just create an alias called more, I could say more is equal, let's say, I'm going to say cat minus n. I just would type in every time I type more, I want to just see cat minus n. So I say more etc host, then it will just do the same thing. So now I just create an alias as more to point to cat minus n, and it will just do it. So if I say clear screen and say, give me a list of my aliases, one of the aliases that I just created was more. And that more is saying cat minus n. And if I say an alias more, now and that alias is gone, and that it's not there. If I just do more etc host, it's not going to be there. So minimum stuff that are there. There's a lot in here that you can get to the system and get information for MyGW. Depending on what we want to do on it, I'll show you later. If we have a need for it, for example, one of the need for it is very, very important when you're working with our program that uses Python programs. And so in that Python programs, let's say uses a NumPy or Matplotlib or some other ones that are an module or a library that is outside of the R language, and you need to install it, you need to install it with pip command. So if I do a pip list, it will say this terminal is going to help you in that sense. Because inside RStudio, you have this terminal, and then in this terminal, these are the modules that are done. Earlier, I was trying to run one of my Python code for plotting sine, cosine, and tangent, and then I noticed that Matplotlib was not there. So I did pip install Matplotlib, and that would just install it. And like if you just do this one, it will, since it's already packages requirement is met, I could see that it is already done. So if I say a pip list and then find a string and then /i and then matplot, for example, that's good enough for it. Notice the find string is not found, but I could say find command, see if the find command is there. That is not there either. So I'm going to say, let's do a grep here. Grep minus I, see if a Linux command, yeah. So since grep is, this one is a MyGW for similar commands that are working for Windows. Some of the commands are working for Linux. You just have to look at those commands, see which one is available under MyGW. But if you are on a VM that is Linux entirely, Rocky, you have to run Rocky commands. The Linux, Red Hat, you have to do Red Hat. Ubuntu, you have to do Ubuntu. Similarly, for R and Python, it doesn't matter which operating system you're using it. They're kind of operating system, whatever the word is, I just forgot the word, agnostic. Agnostic meaning that they don't care. So at this time, I knew that it was there. So you can see Matplotlib earlier, I installed it and it is available there. So if I say, give me the Python -- version, and it will tell me. If I just say get to Python, it will go to Python and say, let's just create a list comprehension. X is equal X for X and for X and range of let's say 100, and then fx mod 2 is equal 0, then print the X. So for X and range, so somehow I mistyped something here. X for X and range of 100. Let's see what inside Python. So the problem is that it does not go to the command that it's there. Let me just say import os.system. I'm going to clear my screen first. And so I could do this one and now say x is equal, and then I say x for x and range of 100, if x module 2 is equal 0, then now x prints all the numbers. So whatever typo I had, maybe I missed a bracket or something on the last statement, which I cannot go back here, but it is there. So if you wanted like odd numbers, you just do this one. I'm going to show you more on this one. And if you say for num in a range of, let's say 1 to 10, range of 1 to 10, say print, I'm going to just say f of this thing and say, let's say num, and then I'm going to say RStudio terminal says hi, right? So we could say that one and then close this one and then that done. So here, if you just want to put a colon after the number, each number it does, you could do that one, and now you will get that information. Say RStudio terminal says hi. So inside the RStudio, we just spin off Python forked a Python interpreter, and now inside Python, I could do everything that I can do within Python. Obviously, inside Python, if I do os.system and then just call an R code, RStudio here, then I'm just dropping into R language. And then if I say here, say, let's say I'm inside here, I could say for num in 1 to 10, and then we just say print. I cannot see the screen because of Zoom. Let me just move this one out of the way. Now I can see it. So I say print, and then say here, I'm going to say hello. Let's do, I could do the numbers as well as lines with the concatenation, C and other ones, but let me see. I could say paste, and then I could say here the number. So I could say num that is there, that will be printing that one, comma, and then the next code is say R console says hi. So we could do that one inside here and then close this one. Let's see if that one there. So for some reason it says unexpected this, the braces for a num in 1 to 10 started and pasted this. Oh, I did not close the, like right here, you see I started this. I need to close this one before I close the brace. So that's one of them, and then the other one is now NAS correction. Our console says hi. So why it did not work? Let me just check on one thing here. I'm not gonna do this one. Let's say just we put it with one statement first to see if it does. Yeah, it will do that one, but the numbers is missing. So the number that is missing, I could do with the concatenation. So the way I did with the paste, I could have just concatenate the two of them together like this. Concatenate this and this together, and now it might do it. Yeah. So and the numbers are within the code. You could just take it without the code because I did this code here, and then this number should have not shown up within the code. But I'll explain that one later. At this time, I'm just going to exit out of this one and then come back to the lecture of the class. Otherwise, we will be troubleshooting and fixing things. And then we don't want to do that one. We were just on the terminal, and I want to show you some of the options that you have. So I'm still inside the Python here because I spin off this one. So if I exit out of Python here, I'm back into my R terminal, which is that one, right? So you can also write a R here, a file .r. If I have a demo, you can see cut a demo one.r, and then that's just printing, adding two numbers. I could source it also demo one.r, and then that would just syntax error. So the error is giving add two functions. This information that is coming from demo.r is not understood by the way we did the source. So let's see if we can open the same file inside the RStudio, whether that's going to be sourced correctly or not. So the name of the function is demo1.r. In order to do that one, I'm going to go to RStudio here, and then let me just go to this screen. On the console, I'm going to say get working directory. So whatever working directory it is there, if I just want to see the list of the files here, I could say file files dot list dot files. You can see that this is a function, so it will just show the files that are there. And demo one.r is there, right? So I could say cut. Let me not cut it. I'm going to just source it. Source, and then I say within double quote demo1.r. I'm going to source it, and notice that it had no errors, because that one was inside the terminal. If it doesn't work for you, make sure that you know that this is GW minimum one, and not the actual code. So there's no problem with this one. In order for me to see the content of this file, let's see if I could do cat this command. And then cat is just doing a cat. But in order to do this one, actually, I need to import a library called fs. So right now, if I say any command like related to the library, I'm not going to see it. In order to do that one, let me just clear the screen here, and I'm going to say import. Actually, not import, I'm inside R. I'm going to say library. You can import fs, or you could do require fs. Either one of these two will just do the work for you. With require, when you do it, if you just load it with library, it will just give you the prompt. With require, when you do it, it's gonna just let's say I say require fs. It's gonna give you a one line of code if it is not already loaded, and it will tell you some information. But you can also detach it and attach it. So at this time, fs is loaded. I'm going to show you. You can also obviously do the attach and detach. Let me just show you the content of it, what I was showing you with that file. So fs : this is called a scope resolution or namespace in R. In C++, this would be a sample of scope resolution to just say the namespace that you're using is standard IO or another one, libraries. It will be defined, like, for example, cout and cn and all of that one, or defined in the standard IO stream. or standard library, then you have to add them with this using namespace. But then, or if you want to use the package without loading the library or without running the library FS or require FS, you just want to use it, and you can do FS and then press tab, all the functions that are available for it, it will show that. So one of the command was like dir info, like to get the directory information and show files, and like you see file change mode, file delete, file info, file move, file show. So file show is the one that is going to display the contents of that file. So if I just say file show, and then you could see, was it the demo1.r, I believe? I forgot the name, but let me just try that on. Yeah, it was demo1.r, and then you can just say open. Now it used by default my Visual Studio Code on this one to open it. So you could see that one. Well, some of the extension, you could just click on these ones when you don't need it. At this time, I just showed you that it is there, the default studio. You could also, since the library is loaded, you could also do file show demo. That will just do the same thing, because I don't need to just say the namespace or a scope resolution. At this time, I know that this package is already available for me. But in order to just to get a list of the functions that are available, you're not going to know every thousands of packages that are there, every 100,000s of functions for every one of them. For example, FS, if I just say FS here, let me just see why. Okay, if I say FS here, colon, look at the list of the commands that are there here, right? So each one of them, they require some arguments, some parameters, and other ones. So like, for example, base, colon, you could see a list of all the base functions here. When you press tab, since I was already loaded, I could just already do all of these ones. Right here, you can do a lot of them. Similarly, if I just say sequence of 1 to 10, with difference of 2, you could do that one and just change this one 3, and then let's do this one to 18. You can get all the numbers between 1 and 18 with the 3 as a difference. You can go vice versa. You can say 100 down to 13 to 18 and minus 3. So you could go downward or upward, depending on. So this is a start and then a stop, and then a decrement or increment. This case is increment. This is the case is decrement. But the start and stop bit is saying that where to start and where to stop bit, and step by what number. Similarly to sequence, Python has a range function. So some of the function that is available in one versus the other one, it is not a problem, because you can write your user-defined function, whatever package or library that is missing, you can write your own function for it. But there's thousands of packages and thousands of hundreds of thousands of functions, so it is very, very easy to find what you need there. So inside the terminal, when we were looking at the second window right here, I'm going to be just getting out of this one. We were talking about sourcing the code, so I got this one. I'm going to clear the screen here. I'm going to do Shift Control 1 to come back to our data structure course. And let's get back to the data structure course to see on the presentation where I am at, so I can continue in a nicer, organized way. So on the presentation, on the page, we were talking about RStudio. We're still on inside RStudio, so I'm going to open RStudio again here, and then click on the first one, which is the structure of the course. So I'm going to delete this line here, and then save it, obviously. And here we are talking about R programming on Windows platform full course from 0 to hero. And if you want to just go to my YouTube channel, you're welcome to go to my YouTube at MyWebUniversity. And that's my channel. There's 1.4 thousand videos, and then you're welcome to just look at them. It's right here, about 1.4 thousand videos. And then if you look at this one, it's all list of computer science related topics, whether it's database, operating system, programming, software engineering, Python, C, C++, PowerShell, Windows, R programming, Bash scripting, everything you can name of it, PDF and MySQL and SQL Server, and then, I mean, not SQL Server, MySQL, and then MariaDB, and then there's a lot here that you can just learn it, PDF files and so on, right? And you're welcome to just go and learn it, and then the entire full course. Sometimes I have it like if you go under my popular, under videos for populars, this video is about 4 hours and 12 minutes. So far, 13,000 people have viewed it. I have heard a lot of nice comments for people that they say 4 hours is not as, I mean, it's very long, but you made it so simple and easy for me to get it. And then some people for things that I'm providing it there, they're thanking me and making nice comments. So please just use those ones. Like if you want to learn Linux to just do a system administration, operating system level, this course is for you. On Red Hat, if you want to do it on Rocky, this course is for you. There's 32,000 PDF files that I wrote Python program to generate the entire Linux manual pages on my website here. So if you go here, I wrote a direct path to Linux Ubuntu, about 14 chapters. The whole book is online available. All you need is a browser and internet access, and you're welcome to learn it and then get a job and then support your family. That's all it is. Just you have the desire to learn, it's already, the resources are there. A lot of thousands of PDF files are there, whether you want to do it on Rocky or Red Hat or Ubuntu. Let's say you want to do it on Rocky, and the thousands of PDF files are all there. Each one of them you click on, you will get a PDF file, and you read it and start learning it, and it's thousands of it. People contributed, and then I made it available for you online, and it's all open source for those files that you can just generate it. As long as you have the GNU general public license, you can do that one, and it is helping everybody. And then if you want dynamic generation of those ones, you can get in my script. Let's say you want to learn Bash scripting, you come here and learn it. And then if you want to just learn something like R language and other ones, if I don't have the PDF file here, most likely I have something for you that is available on the fly. So let's say if I just say R, what would we have for R? I don't recall. Sorry, I just click on a button that I shouldn't have. Click on it right here, R. So if I just say R and then submit here, and then R.pdf file opens up, and actually I do have it. So code reusability, what does that mean? I wrote the program in Python that if there is a R.man pages onto the Linux Ubuntu machine that I have, since I installed R, then R.man pages is there. But notice that code reusability here, there's a GNU.org license documentation, and it's bugs.org dash project. So if I click on this one, it's going to take me to the URL of bugs.org dash projects. So by just moving the bugs out of this one, you don't need to report the bugs. You could say, take me to the r-project website, and then automatically code reusability means this. Now you have the entire manual pages and documentation here. You could just say on the manual pages, click on the frequently asked question documentation or this, and notice that each one of them, they have HTML version as well as PDF version. for an introduction to R, you might want to click on the release version or the patch or development. If you want to look at the one what is released, is better. So that's an introduction to R. Data import is similar, and so obviously R installation and administration. You can click here. Writing R extension if you want to be a developer with R to just support R more and then contribute. You could do that one. Or language definition and internal. Let's say you're interested on one of them, or installation documentation. You click on this one with PDF, and you'll just get 80 pages of a PDF file right here. You don't need to buy books. You don't need to do anything. You just come and do the same thing here. And similarly, if you want to say R introduction to R, you can get that one, and it's about 103 pages. Just start reading it there. Similarly, on my website, as you saw, I went there with R. I could have just typed in, let's say, Python. You type in Python here. You can come in on the python.pdf I provide you here. Look for any documentation that is for docs.python.org or something. If you're not familiar with those URL, you didn't memorize it like I did, you could just come in on my book and then just look for these URLs. And then once you have the URL here, you can also do a find on it and then say, find this information that says HTTPS. Control F and say HTTPS, and right there is python.org page. So now I'm on python.org page. And if you want to just go to further documentation for it, obviously, you could do this one, or just delete this there, and then now you're on python.org. When you want to go to documentation, you're welcome to see the entire documentation for every version there. So if you're well, this is cool. Can I do that one for Node.js, for example? Yeah, you type in Node here and then go on node.pdf. I provide you the presentation here. Let me just go back to this one, make it a little bit bigger. Now you can see that the Node.js stuff is there. Again, if you just search Control F HTTP and then S to get to a URL, that's one of them, and then now there are 6 of them. So the one that is with nodejs.org is the one that you want to click, and now you're on nodejs.org English version. And then here you can obviously go to their documentation page and their downloads, and then whatever you want to learn, you're welcome to practice this one. And all the modules like console and then DNS and operating system, everything is available for you here. So if you're interested to write some OS level stuff, all these Node.js functions are available for you. Okay. If you're interested in learning Java, for example, let's say you type in Java here, go here in Java and then do a Control F again and search for HTTPS. And then right here, docs.oracle.com, it's already have this one. So if you go on docs.oracle.com, I take you to JDK documentation of 12, and you're welcome to start reading there. So this is what I mean by code reusability. By getting into one website, you can find thousands of hundreds of thousands of documentation. Everybody is contributing and dynamically changing. You can get access to them, almost like you're doing a search on Google. The only nice thing about here versus Google is that here you come in and you have a list of comprehension list of it already for you towards Linux and Unix and programming. And then obviously, when you search in one place, it's much easier to search in 10 different screens and then find out one from one, and then find, and they're harder to find in PDF files and this and that. So here you can also search, for example, I say Java, right? So we did already Java, and then Java we already searched, and let's say Go language. For Go language, do I have something? Yes, I do. So you can come in here and then just Control F here, HTTPS, and then see if there's any documentation for Go. Unfortunately, there's nothing here with HTTPS, and there's nothing here. Let's see if there's any URL on Go. Obviously, there's documentation on Google itself. Go language was written by Ken Thompson as a co-developers, and then notice Go and Doc and Go Build and other ones are there. So I could say, let's say, search for Go and Doc. Go Doc is not there, but maybe Go dash Doc. Let me see for the Go language. You can go on the go.pdf and then see also section for it, and go dash build, go dash something, right? And go dash build, and let me just do a go dash build, see if that one shows up. Go dash build. Yeah, so that one, whatever the manual pages, if you remember the name, it is there, because I installed Go language there. So you can see now here, golang.org is the URL that you want to see in this case. So if you look at this one now, you have documentation. So one way or another one, I could find the details of what you could learn from it, and then get the information here, and so much from my website that you can get into these details, right? I'm going to just go back to our class and then go to this session where I said you will find everything on this one. The agenda of this class, again, is R programming language. I've already given you a lot of examples, and you might be saying that, Wahid, you're still at the structure of the course. Yes, but I'm jumping back and forth, and we will be covering some of the topic already, and we will add on to it as it comes. So rproject.org, we already went there, and then the CRAN, we already went there. Last time we already did installing RStudio. We're done with that part, and then installing RStudio there. And then what is R programming language? So R programming language is an open source programming language that is used for basically data analysis, data visualization, and statistical computing, which is a kind of a successor of the programming language S. And then R is inspired by language S. Let me just do Control-Shift-1. And then this screen is going to be the main screen. And I'm going to move this one on the top. So now we can both see easily this information. So R is inspired by S language, which was a statistical software for around 1976 at Bell Laboratory. Earlier, I think I mentioned 73, but I wasn't sure. So I said, look it up. And I think I looked it up. It was 1976 at Bell Laboratory. And then R programming language was developed in the early 1990s. So maybe 92, 93, by Ross Ayaka and then Robert Jankelman. So at the University of Auckland in New Zealand. And so that is New Zealand. And maybe let me start this one, New Zealand. Okay, that is kind of surprised me. Let me just look it up for a second. I'm going to New Zealand. New Zealand is the name. Okay, so I had it right. Z-E-L-A-N-D. And so that's Z-E-L-A-N-D. So let's correct that one with Z-A and then New Zealand, and then that's the name. It's okay if you don't remember every name there, because some people tell me you're from Afghanistan, and I say I'm from Afghanistan. They don't understand. It's like, no, it's not Afghanistan, it's Afghanistan. And they say you're from Iraq, and then the person says, no, I'm from Iraq. Iraq or Iran, they say no, Iran. So sometimes they correct you incorrectly. But I don't want to correct myself like New Zealand, so I just wrote it correctly. However, it is done here. So support R platform, Unix and Linux Windows. R is supported on Unix operating system, Linux operating system, and Windows. And the R session I talked about is on Windows platform. We got the R version information. Now I'm going to show you R packages and R packages and then CRAN packages. So first, let's go to packages. And there's a video also on the R packages and version, which I'm having it somewhere here. Not video, actually. I'm going to talk about the details here. So we'll go there. And let me first go to the next, the data types. So the data types, we're going to talk about numeric, integer, and double. But before I go to the version information, let's get into this one. And then we see the R version. So in order to get the R version, you say R version, which I did earlier, right? So you can get that one, and then that one, if you just run this one and just say run, you will get the output there. And then obviously it says R version is a function, which means that if I just run the same code, I have to do it as a version like this, and it will get the system version. And then earlier I showed you some of these columns as $. Architecture will give you this, $. OS will give you this, and so on. So what I mean by that one is, like, for example, I up arrow here and then say $. OS, and then that would give you MGW. And then same thing with the $D would give you 14. So I'm not going to go through each of those examples here. Okay, so that is the R version information. And also you can get it R version from the about page on our help. It will just tell you that you have the entire thing. And then right here, you have the about page. About RStudio, it will tell you that you're using 2024-04-02 build 7064, and this is the details of the R version. You can get that information here also. So whether you use R.version or other information, you can get that information here, okay? So let me go back to my studio. Sorry. Control-Shift-1. We're back into this one, and we were right here talking about let me just go one more screen here. So we were talking about R version. I showed the R version, R base packages, and then R CRAN packages. So by default, base package is coming every time you close this one. If you close it, and then automatically you have the base packages. Certain packages are available for you, and if you just are in there, it's also available for you. So whether you use the base package by showing it here, let me clear my screen here. So now here I could say base colon, and then all of the absolute value function, or cosine, or sine, argument, sequence, all of that functions, arrays, and then as is, data dot frame, vectors, and factors, and list, and functions. Everything is part of the base function, which is the operating system. I mean, the R programming language supports this base package to do entire things with programming. It allows you to do all kind of data types and data structures and everything. So this is the base package here. So you can see the list goes on and on, right? How many functions are there? Like, for example, some of the package that are part of the base, like, for example, let's say I just type in sequence and then say 10 to 100 difference by 25, I'll get those numbers. And if I say get it by 5 difference, I get those ones. And if now I say what is sequence, and then I could say get help on the question mark sequence, as a function, it will produce an output here for me saying that sequence is this. So if I go Shift Control 4, and this is the other one. Yeah, I think Control Shift Control 3. Yeah, this is the sequence. So it says it's part of the base package, and it's all the details are here. So telling you how to use the sequence function. So if I go back here with 1, and now I did this sequence here, I know that this is telling me that this is a package that is part of the base package. But if I just say, okay, I did that one, and now I say base colon sequence, and then I say it's a sequence, right? So I could say 10, 100, and then let's say 30 difference. Then that will produce it. Since base is by default is loaded, I don't need to write base in front of it. So I could use that one. If I say find command and then say what is sequence, this one is saying that find me the package name, the function name sequence where it is defined. It says that it is defined in the base package. So that means I can type in this one because it's part of the base, it's already loaded. If I go under the package here, and then I look at the list of the packages here, let me just see, base is base 64. Somewhere here, it should be just showing you, if I sort it by name, base is a little bit higher, right here. Base 64 ENC. That is the one that is allowing it there. Inside this package also base itself. So if I just say, let's say, I cannot detach base because it's part of the core part of the OS, right? But I can just load another package by just installing it if it is not installed there. So if I say, let's go with a package called tidyverse, for example, right? So here, if I say tidyverse, notice tidyverse is a package that has a class of packages that are all together provide a lot of packages, a collection of packages. And each package by itself either has thousands of functions or thousands of functions with documentation and properties and attributes that are available that you can use inside that package that is involved. So like here, you can see with the tidyverse, is a lot of these are listed here. But if I just say, well, let's say if this package is already installed, because I used it in the past, I said install the package, and then packages, and then let's say tidyverse. So this one, since I already installed it, it says that this is already installed, right? Do you want to install print install version? I could say no, don't install this one. Updating load packages, since I already installed it in the past. Let me make this screen bigger here. I could also click on install here and just type in the word install. I mean tidyverse. Now notice that as soon as I type in tidy, all of the package that are related to that name is going to show. Then I say tidyverse, and it's going to say, okay, tidyverse is a library that I can get to install it. If I click install here, it's going to go through the same installation the way I did it from the command line. I'm going to say, no, don't install it. I want to just load it if it's not there. So I'm going to load it two ways. I could say library tidyverse. So notice that as soon as I type in library tidy, whatever packages that are available, it will show a list of them. And now I can put it within double quote is better, but I can know that it already detected. It will just load that package for me. And notice that when I load it with the library, it says that these are attached library within this package tidyverse. We have dplyr, we have forcat, and we have ggplot2, and so many other ones, right? So each one of these package or part of these dependencies that are coming with tidyverse. As soon as you do the tidyverse, all of these packages are available. And at the same time, if I just say, okay, what are the conflicting packages? So you can see the dplyr package, which is part of the tidyverse, dplyr core packages, and dplyr is there, but there's a function called filter that is also defined in the stack filter package. So if you type in dplyr colon filter, and notice that dplyr filter, this package is there or not, you could get the information from it, but let's just not use it. I want to put a question mark in front of this, and then I say, give me a this function, help on it, right? So I want to see the dplyr function. When you do this one, it is oh, yeah, that's why I mistyped it with E. There's no E in front of it. That's why. So no wonder when I did the library here, this loaded, and then this one was not detecting any of these functions that are available with dplyr, and one of them is filter. So as soon as you type in filter, it will do that one. So when I do a question mark on this one, say, show me the function filter, notice that filter is coming from dplyr here. Remember earlier I was showing that it's conflict. So if I do this one with the stats also provide filter. And then if I just do this one, say FIL, and notice all the functions that are available, one of them is filter. So you could do this one, and you can see that filter is also provided by stats. So if you see a function that is defined in two packages, think about it, this is open source. Somebody in Germany or Afghanistan or Iran or United States or Russia or China, they're still coding in the open source community. They're Finland, whatever, all right? And they're writing code, and then they may be just writing a function that is called a filter. They may have 2 parameters or 10 parameters or different arguments versus another person, another place, an open source community. They are doing the same thing with different ones. So that's why you have conflicting ones. Make sure if your code is having issue, make sure you do this command, say find, and then say where is filter used. So this one is saying that filter is also defined on the dplyr package as well as the stat package. So then it's your choice to go by the functions as a developer to code it right with all the filter that you're doing inside dplyr or inside the stats, and depending on what environment you're coding. And then sometimes proprietary software like Microsoft, when you're looking at the library, dynamic link library, it's only written by Microsoft. So when you go to documentation, it's much easier to just have no namespace conflict on a library with some functions are defined on 2 different packages. But also with the Sun Microsystem, when they were writing Solaris operating system, all these shared object files and similar to dynamic link library, it is there by Oracle. So it's much easier for them to do it. But when they make it open source, like Open Solaris or Linux or Red Hat or any other ones, Red Hat now they just changed the licensing to, just because when they were bought by IBM, and then they are not releasing the open source, the source code of the Red Hat to the community, and the state they just said, well, you can use the Rocky version or the older version sent us, and then Rocky is really cool and it's open source, so use Rocky. I would use Rocky. So at this time, find filter. I showed you those two packages here that are available on this one. And then at the same time, right here under the packages, if you click on this one and look for the tidy package here, let's see, MNOPQRST. So T is somewhere here and tidy. Select tidy verses here. Notice that tidy verse is selected as a check, which means that it is loaded. If I uncheck it, this one is running detach command package, tidy verse, and unload is equal true. So I could attach it there and detach it as well. So now if I say require, last time I loaded with library, this time I'm going to do with tidy verse with require. And notice that when you use the require, it gives you this output here. Okay, so now tidy verse is loaded. So like for example, R MySQL, right? If I uncheck this one, it says uncheck detach package this one. But if I want to say library or MySQL, then it will attach it, and then notice it checked it again here. And then I could also up arrow here. I wish Zoom could be just put on the side so it doesn't interfere me. Maybe if you're a Zoom developer, please work on that environment. So right here, notice that if I want to detach it, I could say detach package this one. Notice as soon as I press enter, this will be detached here. And that is now detached. And if I want to just use the library, I could do it, or I could say require similar, and then the require versus library. Notice the library did not say much, but require, it will say loading required package or MySQL. It will give you one line information saying that it loaded that. So similarly, if I go to the here on the file system, let's see, under the F, right here, file system is loaded right here. I can say detach, my cube. Can I just change it here to make more typos? Detach, detach, and then I could say package colon, and then file system is the package name, and then unload is equal true. So you could, for sure, you could type in T for true. And then now the file system is detached. If I just say here, like dir underscore dir underscore ls, because that package is not there, it's going to say, I don't understand dir underscore ls. But if I say library fs, and then I just get that one, now fs is attached, now I could say dir underscore ls, it will just give me a directory listing here. And if I say dir underscore info, it will just give me the info on that one. So there's a lot of commands, like just type in dir underscore. Notice that you have dir copy, dir create, dir delete, dir exist, dir info, dir ls, dir map. Dir tree is really cool, like a tree command of OS. So you can get a directory tree of this one. If you're on the terminal, you can run a tree command. And if you're on the R language, you could do a dir tree. So there's a lot of commands here that you could do file system. If you don't remember the name of it, you could type in fs : and it will give you a lot of the thousands of functions that are available, right? Path information. So if I say give me the path, I could just type in path here and it will tell me the path of there. I could also say path like this, it will do the same thing. Or if I say find and the function get working directory. Let's see where that is defined. That's on part of the base. So if it is not finding that one, I'm going to write it like this and say find, and it's part of the base. You can see. So get a working directory is a function that will just show you the print working directory that you're doing it. So if you want to just change your working directory, you could say set working directory here, and then that's again part of the base package. And then I'm going to say C, and because this is main GW, I have to put the /, which is like Unix, like this one. So Windows system 32, and then you can see that I'm on this directory. Now, say dir _ls, it shows me all the files that are dynamic link libraries that are there. And you can see that it is a big list here, right? So, and then there's a lot of executables as well here. And then files dot list is part of the package already. So list.files, sorry. List.files is already part of this. So all the file with the executable listing, you can see there's thousands of files, right? 1,000 files altogether. You can see that one. And list.dirs will give you the directories there. So all the directories that are there, you want to get the list of them is there. But notice that I did a find. If I say list.files, this one is in the base package, right? But the command dir _info was on the file system. So depending on the package, if the base is not base comes with it, but if FS is not loaded, make sure you load the package with this command there, or just right click here to detach it and click on it to attach it, library. As simple as that one, or just type in those commands. Then you can type in all the FS related commands once you load it, and then just look at them and that are there, right? So the set working directory I did, I think. Now if I say get working directory, because I set it up to Windows System 32, it's going to change that one. If I wanted to save that working directory, whatever it was by default, I could have just saved it into a variable, which is a vector also itself. So the data type that we were talking about earlier, you could do that one. And then I did not save it. So let me just exit out of this one. I'll show you something here. I will open back here. And then once you see the RStudio here, your environment, whatever you did last time, it is saved on that status. So if I just say, give me the get current working directory. At this time, it's back to original directory here. So earlier I did not save it. I will show you how to save that one. So now if I just do this one and then say current working directory is equal this, right? So I could say a variable current working directory is this. Now current working directory is pointing to the same thing get working directory is, right? So at this time, if I just want to say, that's great. Now I want to say set working directory, and then I will change it to this. There's also under menu, you can do the set working directory, but I'd rather memorize it on command prompt. It's much faster than just using a studio, because when you're on the console you don't have those capabilities or luxury. So I'm going to say set : Windows and system 32, let's say. I do this, and now I say get working directory. Notice now my working directory is there. But because current working directory is saved, I could say set working directory, current working directory. That one, I will just set it. Now I say get current working directory, and back to square one. So, and instead of the Windows, you can do that. So we talk about packages here. I talked about CRAN packages. CRAN packages are a list of comprehension packages that are available for you. You can use the install package to just look for it. Like you could say R and then whatever package, let's say MySQL. As soon as you type in my, and it says that I know there's a package called MySQL. If you type in SQLite, and then it knows that it's SQLite. Remember, R is case sensitive. So R is uppercase, SQL is a structured query language or standard query language. It stands for SQL. SQL is uppercase and ITE is lowercase. So make sure that when you install this one, you just choose that option. If you do R Oracle, you can see that our Oracle is there. And then R MySQL, it is MySQL there. So R MariaDB, it's there, MariaDB. So as soon as you type a little bit of it, it's going to help you to say that what are packages that are available here. And then the option that you have here, let's say you want to do MariaDB, and then you just look at this one, then it says install it or match also the dependencies. So the dependencies of our MySQL or MariaDB, DBI is one of them that it's going to come with it. So you need to install it, and I'll show you how to do that one. By just sometimes installing tidyverse, you get a lot of dplyr and other ones. Similarly for MariaDB or MySQL, you get the DBI and other ones. And then like object database connectivity, RODBC. See, and this one stands for object database connectivity. So when you're working with Oracle, MySQL, or Informix, Sybase, Microsoft Access, sometimes you want to connect remotely to a database through a socket or connection, and then you use object database connectivity, and you're doing API calls through that, and you're good. But at the same time, you're going to connect to some of the interfaces like MySQL and other ones, we could do that one. And then here, you could also, under the packages, you also have option of updating it. So if you want to say which package you want to update, you can update it. If there's not the latest version, for example, for PS, you could do that one. PS is like process stream tree, and then process related commands. So on the terminals, you could type in PS, and then here, like for example, say clear screen. Clear screen is this is really small. So let me just clear screen here. And then say clear PS minus EFA, and then you see the process there. PS by itself is that, and then you could just look for processes there. But if I just did the library, and PS is one of the library that, let's say I load it there, and then I just want to put it within double quote there. So this one, it says I did not understand syntax of PS. So remember earlier we saw something with PS. So I'm going to say install.packages, and then just say PS. If it is not there, I'm going to try to load. Oh, sorry, I'm on command prompt. On the command prompt, so I don't need to be in here. I meant to be here, typing in here. So sometimes, like I'm a very command line person. So here I'm gonna say library PS. I think PS is already there, and now I just loaded PS : and then all the functions are there. If I want to see the process itself, you could say, give me a list of processes and on the system that is there, including R itself, you can see that one. So PS : and then you can see a lot of other information, command line information, child process, CPU time, and there's thousands of other ones. Process exec, and then find tree, group ID, parent process ID, and so on, running processes. You want to do so the list goes on, and then someday I will provide you, if you're interested on this one, ask me a question and I will make a separate video for you if you are interested on that one. At this time I'm going to say detach it, or if I don't need it, I could also detach it. Sometimes it's good to detach things that you're not using it, because your system resource are not going to be hogged with something that you don't need to run it. So detach detach and then say package yes, and then I'm going to say fs and then comma and load is equal to, and that should detach package maybe. So why is it invalid and name argument? Let's see on the here the syntax that you do fs. I gotta find ps. Sorry, pqrs. Yes. So when you do detach, it says detach package colon. So I put that. What did I type in? Package colon fs and load through. Let me see what I typed accurately. So when you do this one, it says detach package. Okay, it was not attached. That's why. If it is attached and then you do this detach, if it doesn't work, the only reason it wouldn't work is here is detach. Let me just do the detach from the menu and see if maybe one character is mistyped. Yeah, detach package and then package fs. Oh, ps, not fs. The package name was inaccurate. So I was thinking of ps, but I was typing detach ps. Now fs. And now if I want to detach that one, I just have to up arrow here and then do the detach here. Even with that one that I had line fs, I could just say ps and that should work, and that does work. Okay, so the syntax was correct. The name of the package, I was mistyping it because earlier I was working on fs and I just look at ps. So right here, I'm going to clear my screen here. I'm going to come back to shift control 1, and then we are right here on the package here. So on the documentation, in order to get documentation for anything, I'll show you many ways you can get help on R language. So if you're on the web, obviously you can go to r-project.org website that we went there, and then I showed you the PDF already. There's something RShowDoc is very nice also. RShowDoc is going to show you information on PDF as well as other ones. So if I just go back to this screen and then say number 1, and right here I could say RShowDoc in order to just get help on what is RShowDoc. I could say RShowDoc. R is the R language show documentation. And then this one will give you detailed information how to just look for R documentation, whether you want it on PDF format or HTML or text. So you can see that R doc, what documentation you want. The type is either PDF or HTML or this, and then the package name. So here there's some examples already, RShowDoc, R language. So if I just run this code and then Control C out of it, and then here say, give me documentation on R language, RShowDoc, it's giving you a very nice documentation on PDF format. Okay, so you could just go on the website, find it, or just inside the console, you could get the same information here. So coming back here, let's say you want the frequently asked question in HTML format, you would be running this one. So this is a very, very nice tool. All you need to do is memorize one command, RShowDoc, and then do a help on that one. Then now everything is available for you. Code reusability, again, you could just do the same code. You don't need to memorize so much of, oh, I have to pass in this argument and with this syntax, because sometimes the developers on every platform, they write something different set of steps. So for example, here, let's say They are getting a package name in text format, frame, script, and let's see, that one is, I'm going to say for one of them, let's see, RDoc or ShowDoc, and then news and change text or language. Type C, PDF, or text ShowDoc. So if I want to just run one other one, like package name of mass. And so this is going to give you news on it. And then instead of news, you could type an index of it or something. And then let's see if we just type in this, and then you get the information for the news of that one right here for the mass. And then let's say you go, if there's any news for tidyverse package, you could do that one. The package name, all it is a different package name. Let's see, mass is, maybe mass is not the name of the, package name is FS. If it is loaded, the package has to be loaded. I think it is a library FS, and then now we do that one. No, news, there's no news. Let's do an index on it. Yeah, so if there's any documentation on it, you could get that one, but since some of them may not have it, so depending on what you have available, what you don't, you can look at that one with RStudio. Let me see if on this one, aside from the information that I put here, or information. Somehow on the screen is just still working on save selected. Now don't select and don't save it. And then close this one. Oh, close more than what I should have closed. That's okay. I'll just open it up again on the language here. Okay, we were demonstrating the ShowDoc, which you saw some of the help there. And then in addition, under the help here, you have a number of helps that you can search for it. And then also right here, you can search for documentation for like R and then show and dot. And there, and you could just get the documentation as well. And there, and then so some of the frequently asked question or something. Let me move and zoom out of the way. And right here, this one, and cancel this. Okay, our language, we already showed you some of this one, but what other things you could do is on the R console, you can type in command like question mark, and then say, for example, let's say you're looking for sequence function, you could do that one and then get a list of the help on it basically. Or let's say show me the standard deviation function, it will just do standard deviation function. Or just say give me the factorial function, question mark and then factorial, and then it will just give you factorial definition of that, right? So a lot of the you can also type in the package name. So for example, if a package name is already loaded base, you could get that one and the package name, and it will tell you and this. You could also do, let me just make this screen bigger. So you could also say, for example, library, and then say help here, and then is equal, and then the package name is, for example, base. So if you're looking at that, you could see the base package with all the function calls that are there, everything that is available, the version of it, all the functions that are available, everything will be listed here. Okay. Similarly, you could just replace that instead of the library name being that, you could just do anything. You could just say, give me the stats library. So that will just change the stats and it will give you that information on the stats packages. So depending on what package or what library, you can also use that fuzzy search. So if you're saying it is called like something like table, then maybe you have the whole word, you could type in a table like that, and then it will, or will just find out all the information that is matching anything. It's because it's a fuzzy logic. It's the search is adding more of the string table similar everywhere, right? So, but if you just only do one question mark table, then you will see that list of it's more kind of function that is available for you. This similarly, like if we say as.data.frame. What does that do? And then you could just type in, and it will say coerce the data frames to convert it. And then if you say, well, that's good, as is going to coerce it to a data frame, what about the is? It's like object-oriented kind of things to check the functionality of it. It's returning a true or false. Is that data structure a data frame or not? So whatever you type in here, it will check it. But similarly, if you say question mark is dot factor, you could get all of these ones are there as dot factor. And so in this one, if you just put a question mark, it will give you help on. So I think I give you enough information for that help. And then now let's go to the next topic on the agenda of the class, which is under the structure. We were talking about the structure. Let me go back to the structure here, right here. So we were talking about the our documents here, and then the next one is our data types and data structures. So now we're coming back to data types, right? The data types, I told you there's a numeric, integers, double, complex, and logical, and characters, right? And the order of precedence is the characters, the higher, complex, and logical, and the other ones. Logical is the least one, and that you have preferences or logical of order. But when you do coercing, usually if you have two different data type, everything changes to character if you have one character in the data set. And if you have in number and logical, then it will change it to numbers. So we could do that one information. You can also do a static kind of conversion, which with using these ones to do as a dot data dot frame to change it to a data frame or something else. And also inside R, there's a lot of data sets, and data sets by itself. So if I just undo this one, I don't know what happened here, what I had there. I'm going to undo it. Okay, so R character. So now this information you can see here, we're on the numeric numbers. So if I want to just do something with numeric, let's say 1 to 10. I just want to run this one. It will just print 10 numbers, right? And if I say, give me the type of this one, type of this one, it will say the data type is integer. And then, so if I want to get this numeric, this one, let's say I type in L here, that will be also integer, right? So L1 uppercase R defined it like that. So then I say type of integer, it's still integer, right? But if I want to get, let's say I want to do something with this numeric is all kind of numbers or numeric. Integer is also numeric. Then so let's say I go class of this one, class of 1 to 10. I want to see also type in like that here. So if you run the class of this one, it is just going to say that's also integer, right? Now I'm going to cut and paste this one under the integer. It still is going to do the same thing, right? So this time I'm going to say this, but I'm going to take the L out of these ones because numeric or could be any number there. So I'm going to take L is because the second one is integer. So you could say that this is these two are class integer and then type of integer. And then here also is going to say, sorry. So I'm going to just not highlight it. I'm just going to right click and then goes to the next one. Type of it is integer. Now, if I just do R double and I say X is equal, let's say I define X is equal, this is an assignment statement, you say 2.5. Now I just create a double floating point numbers. So now if I say type of X and then class of X, you can see that it is those data types, right? So I'm going to say run this one. First, it assigns 2.5 to variable X. Then I want to get the type of it, it says double, and then get the class of it, it says numeric. So I'm going to move this one a little bit here out. And then now let's do logical. Logical, I'm going to say create a L1 for logical one, and then assign it to value of true. I could say T for true, or say L2 is equal true, all in uppercase, and then L3 is equal false, and then L4 is equal, let's say, word false. I cannot write it in lowercase. It's only understanding one character or the other one. So if I just say this, run it, it's going to assign it. But now if I say type of L1, you can see it is logical. Similarly, if I run all of them here, I could just say run all of them, it's define it. Now if I say go type of L2, it's going to say logical, L3 is logical, and 4 is logical, right? So then I could just do a for statement to say for all of them to show me type of them for those variables there. Or I could just make a concatenation here, say L1, and then say C, and then here, this concatenation function, it puts this true, false, true, false, or just true, true. Let's write same thing like false, true, and false. So I could have those ones and just have one L1 type of L1, and then class of L1, because I could create a concatenation. This one, when I run it, it just creates the L1. Now L1 is a type logical, and then class of it is also logical. But if I want to get L1 sub 1, and that is true, correct? So if I get L1 sub 1, you can see it is true. L1 sub 2 is gonna give me false because that is false. So if I want to say L1 colon L8 because there are 8 of them, I could get all of them at one shot by doing that colon, and it says true, false, true, false, true, false, right? And then if I want to get subsetting it for like a small portion of it, maybe 3 to maybe 4 to 8, then it will just say the last 4 digit here. So you have a choice to how to do that one, but that's logical. And then complex is a number that the data type is saying that, like for example, C. I'm not gonna use the C as itself, so I'm gonna say complex one, C1, because C function is a function here. So if you do just C by itself on this one, like here, you say C and then press enter. If you want to execute this one, this is a function. So if you type in question mark next to it, it's gonna just when you run it, it's gonna say this one is a C combine value or concatenation value, and this is the syntax. We used it there. And if you just do it without this and just run it like that in lowercase c, and then you run it, it will just tell you this is a function, right? So function dot primitive c. So you could know that one. Now, since I'm creating a complex one, I'm going to just say complex one and say, let's say 0 plus 1i. And so it's 0 plus 1i, meaning that it's an imaginary number with a real number, right? So now if I say type of C1, it is there, and then a class of C1. You want to just get those information here. So let's run this one to see. First, we want to make sure that, oops, it moves so fast. Come on. Okay, now it just lost the connectivity for a second, and now it's back. So now I'm on the class. If I just look at this one, C1 complex one, and run it, it just says C1 not found. And because I used the double greater sign rather than this, I meant to write this. Now let's save this one, and then I run this one again. Now it says that C1 is defined. So what is the type? It says this is a complex. And what's the class of C1 is also complex. So if I want to say C1 is, I want to add up some number to it. So C1 plus 10, let's say, you just use that complex number, and it is there with that information. So now say C1 printed. So notice that if I run this one, it is C1 plus 10, and then C1 value is now 0 was added with 10, that's 10 plus 1i. That's how complex works. And then you could also do multiplication, the same thing, C1, so whatever C1 now is 10 plus I, so I could say C1 minus 10, subtract first. So let's go see if we get back to the number that we wanted to have, C1 here, and that should work the same way here. And then C1 is now 0 plus I we had. But if you want to do multiplication, C1 on the complex number, say C1 times, you don't have to assign it every time. You can say times 5, and it will just get that one. As long as you run it here, you will get 0 plus 5, 5. Because 0 was the number, and then 1 was multiplied by 5. Okay, and then this is also allowing you multiple matrix multiplication. Like here, I did this one, so I could do also with C1. You could say C1 times 1 to the power of 5. So I mean to the 5. This one is not allowed here because I used it with brackets and it is not understood. If you do it within the parentheses, it will understand it because that is the right syntax. The other ones, it says it's a dice, and it's not a dice. It was just a range of numbers. So you could do that. Similarly, with the range function, you could say 1 to 5 times 5. You could just multiply every number by 5. Or if you say to the power of 5, get the number bigger. Or get that number factorial of that. So all of these functions that are in the system can do those ones, factorial functions. Later on, I'm going to show you how to do factorial. So if you say, get me this one, and then at the same time, just sum it up to see what is the summation of those numbers, you could get that one. So if you say, give me this, that's the 1 plus 1 is 1, and plus 2 is 3, and then that's it. If you do it plus 4 here, it's going to be 33, and plus 5, notice the number goes bigger because of the factorial addition, right? So if you do times 10, the number is much, much larger. And then you can also get, like, for example, sum of 1 to 5, you could get this one. If you want to do, instead of sum, you could do product of it, multiplication or product of that list. So those functions, like I did find, you could say sum, that's part of the base package, right? It's coming there. Similarly, product is the part of the base package. Similarly, standard deviation is there. Similarly, absolute value. All of these functions that are there are part of the base functions, right? So if I just did not close it, that is just not understanding it because I did not close it properly. So now it is sitting there, find slash. What I could have done is double quote, and this is as double quote already. So I'm going to clear it and then run this find command with the absolute value, and you'll see that's part of the base package. Similarly, for a package like sequence was part of the base package. What about mean function? There, median is base. So anything that is different on the other ones, you could see median is part of the stat package. Base was mean was part of the base, and some of them are part of the base, some of them are stats functions, but you can find them there. So we're on the data type again here. I just jumped in a little bit, digressed, but we're coming back to whatever topic we were discussing. So I'm going to now define characters. So characters are similar. So if I just create a vector of characters, say character 1, earlier I used the word complex. Now I'm going to use this variable C1 again. So in order to get a list of variables that I have used, I can do ls and then this functions here. So all of these variables are in the system, and then right now it is being available on my list of functions here, right? So if I just want to say, what is C1? C1 is type of C1, type of C1 is there. So Python is not a strongly typed. C and C++ is a strongly typed, and then R is also not a strongly typed. You can define a function, a variable, and then you can cast it later on to something else. But once you define it, it's the data type determines what type of character it is. So similar to Python, our language is strongly typed. In fact, I spoke earlier. So it is a strongly typed because you can just type, define it, and it creates it. But now let's say I want to redefine the C1. I could say C1 is in my list, and I could say ls of C1, just list it, and then it says, okay, this variable, maybe you could put it in the code. It will just try to list it. It says, I don't understand that format, but I understand this format, and then that will just show you C1 is one of them, right? C1 is right here. So if I just say, okay, that's good, can I remove that one? I can say RM and then C1 here, and then that will just delete it. Now C1 is no longer there. I could define C1 to be a complex number and say 0 plus 5, and then now C1 is there, unless of this one is showing C1 is back there, and type of C1 is already there. But then I could change it to a C1 to a character. So can I just change it to a characters? Yes, I could say C1 is assigned to a character A. uppercase. Now C1 is their type of C1 that just changed. That is manually casting it to a character type, right? You could also do a C1, let's say from one data type to another one, you could say C1 is equal, I'm going to assign some letters, letters, let's say 0 to 26. All the alphabet lowercase characters, I just assign it to C1. This is like an object that it takes argument. You could say 0 to 5, and it will just only be the first 5 characters. And then if you want it in uppercase, just change this object name to all uppercase letters, and then just have those letters to uppercase. Maybe I mistyped letters. Yeah, it's harder to see from far away. C1 is lowercase, and so now it's on this one. And if I want to do that same thing with 26 of them, obviously it will be those 26 letters. So you can also do as dot character, right? You see that is there, or is dot character to check for the condition, and then is dot vector or as dot vector to convert it. So all of that one is also available for it. I need a quick break because I'm getting a little bit dizzy, so give me a couple of minutes. Okay, I'm going to make 2 sessions on this video because the video is getting very long, and I think my computer keep choking at some point, and I cannot type in, or if I type in the command, it is just not responding at all. Now it is responding back, so I'm gonna hope that I could have this video, 2 of them. I will just provide you this one as session 1, and then a second one to just continue on with the rest of them, because there's a lot to cover. Take care. God bless you.